Welcome to Sundar's lecture. This is actually lecture number 79, and in this lecture we are going to see transient responses for RLC series circuit with AC input in MATLAB. Before that, let us see what are the topics we have seen in the previous class. See, we have taken a circuit with RLC and the input is 10 sin omega t. We have taken in the previous class, right? L is equal to 1 Henry and C is equal to 100 microfarad, and the value of R we have varied it for different cases. For first case, we have taken it as critically damped condition, and here we have taken R is equal to 200 ohms, right? And then we have derived the expression for V of t and I of t. As well as in the second case, we have taken it as overdamped condition. Here we have taken R value as 300 ohms and we have derived V of t and I of t expression. And then for the case 3, we have taken R is equal to 100 ohms and we have derived the expression for V of t and I of t. See, we are going to draw the three different circuits for each cases in MATLAB, and let us see what is the graph we are getting for V of t and I of t. Even if you put the value of t here in V of t, I of t expression in all the cases, you will get nearly the same values in the graph as well as in the manual calculation we have calculated in the previous class, right? For that, we have to go to the MATLAB and then we will see what happens with the MATLAB, right? Now you see we have opened the MATLAB, and in MATLAB you can see a Simulink block here. Go to the Simulink and you can see a blank model here. Create the blank model now. Now you can see you will get a blank model like this, and you enlarge this. Now you just try to save this first. So you save it as online underscore RLC maybe circuit. Circuit, that's all. I have saved it, right? So now what you do, you just double click here. You can see a create annotation block. Go there and you get the RLC series branch. You can get like this. So you just copy this and then paste it out. Again paste it out. You can see three different RLC blocks. Go to this first one. Go to this branch type and you select R here and then click OK, and go to the second branch, and in branch type you make it as L and click OK. Go to the third branch and in branch type you change this as C and click OK, right? Now you see you just click this C block and press Ctrl R. You can see that it can be rotated, and what you do, again you double click here and you need AC voltage source, right? So AC, you just type it out AC voltage source, you will get a AC voltage source. Keep it here, and we are going to measure current and voltages, right? So what you do, double click here and you see current measurement. It is here. Get this to here. Get this current measurement, and also you need voltage measurement. You just voltage measurement, you can see here it is voltage measurement. Keep it here. That's all. Now we have got everything. So now you try to connect this diagram. So input, we are just connecting it in series. So it will be connected, and this has to be connected, and this will be connected. That's all. Series current measurement will be connected in series because we are going to get what is I of t. I of t in the series circuit will be same in all the elements. There is no difference. But what we are going to get as V of t, which is nothing but it is voltage across the capacitor, right? So you need to connect this across the capacitor, this one as well as this one. That's all. Now you see, go to the AC voltage source. We have got amplitude as 10 volt and the frequency as 50 hertz. So click OK, and then you see it is R block. What is the value of R? First we are going for critically damped. So it is 200 ohms for critically damped, and L value we have taken it to be 1 Henry, and this initial current we have taken it as 0, and for capacitor we have got it to be 100 microfarad, and initial voltage of the capacitor we have taken it to be 0, and see we have created the diagram, and you just double click here, type it as critically damped, click directly enter, that's all. You can see a text block, and this is critically damped. See, we have to go again, you double click here, get go to block. I will tell you why we are getting this. So you just connect this go to block here, you keep here, and you connect this go to block, and again you copy this and paste it out. Sorry, copy this and paste it out. You can see, and you connect this one. See, this is current one, current, right, current block. So I1, you just take it as I1, and this tag has to be V1. That's all. Now we have created the diagram, and what you do, you just copy this whole blocks, copy, and you just paste it out here, and you can move this right side. This is the second case. First case we have taken it to be critically damped, right? So this is critically damped, and now this is we can take it as over damped condition, right? So that is the case 2 we have seen. So this is over damped, this is over damped, and for the over damped, what is the difference? This R, it has to be 300 ohms, that's all, that is the only difference, and this tag should not be same. So you take it as I2, click OK, and this tag has to be V2, that's all, right? Now again you just paste it out and move this one, because we have 3 cases. First case is critically damped, second case is over damped, and the third case will be under damped, right? We have seen this one in the previous class. We have seen all these kind of things. This is under damped, right? Under damped. For under damped, what is the value of resistance? Resistance has to be low, and we have taken it as 100 ohms. So please refer my previous class. You can see this, and this tag has to be different, right? So it will be I3, and this tag has to be V3. I'm just taking it to be V3. That's all, right? So we have created everything. Capacitor, is there any wrong? Okay. Now these are all the 3 diagrams under now what you do, you just double click here, get mux here, multiplexer, and you just again double click here, you make it as 3 input, and little bit you can enlarge this maybe. So now what you do, you just click again here, get a from block, this one, you keep here, just connect it down. See, again you copy this, paste it out, keep here, again you paste it out, get here, make it clearly, and has to be visible. See, these 3 blocks, what we are going to do, we are going to get this 3 current at the same max. So you double click this one, click update tag, it will be updated. Now you can see there it is I1, click OK, and for the second block you just get I2, and for the third one you just get I3. That's all. We have got the blocks. Now again you just copy this, simply you just copy this, paste it out, move down, move down, and you go here, get V1, get V1 for this, and then get V2, and then get V3. That's all. Now what we have done, we have just got all the three currents here, all the three voltages here. Now we need to display the voltage and current in the same graph. So for that, double click here, go to scope, get scope, and you can see a scope here, and you just double click this one, and you go here, files, and you can see number of inputs in this here, get 2, and then you close this. Yeah, now you can see it clearly here. You can see 2 inputs here. Connect this input, connect this one here. Now now you can easily understand, right? We have got 3 circuits, and in 3 circuits we have both V of t and I of t, V of t, I of t, V of t, I of t. All the currents we have taken it to a mux, and all the voltages we have taken it with another mux. Now this whole 3 currents will be given to the first input of the scope, and this 3 voltage is given to the second input of the scope. Now in the scope we have to change some settings, and then we can see the output of the these 3 circuits. Now what you do, you just click this scope, double click, go to this point, and you can see the third block. You just click this, and you select first 2, and you can see 2 like this, 2 blocks like this. And now what you do, go to this settings, click this settings, and you can see these type of inputs here. Sorry, what you do, you go to the settings, get this paint block, you can see like this, make it to white, and this color to white, and this color to black, and click OK. Now you can see the background will be very clear, right? So again what you do, go to this paint block, and the 2 displays, first display you can see 2 active displays, because we have selected this is one display and this is the second display. In first display we have connected the current one. See, try to understand things very clearly. This is current and this is voltage block, right? So be very clear with that, so that it will be very easy. Okay, and this one, right? So this is the active first block, the first channel, that means we have given 3 channels here. So first channel, and this line you make it as 2, and this current to be red. We will take RYB, because first will be R, second current will be Y, and third current will be B, so that we can differentiate, right? So you just do this and click apply, go to second channel, and make this to be 2, and this color to be RY we have told, right? So RY, and then channel number 3, you make this as 2, thickness, line thickness as 2, and this color to be B, apply. Now we have done for current. We have 3 inputs, one is R, one is B, one is Y, and now you go to active display 2, there you can see channel number 1, and you make this to 2, color to be red again, red, and channel number 2, make it to 2, this is Y, apply, and then channel number 3, make it to 2, thickness to be 2, and this has to be B, click OK, apply, click OK, that's all. Now we have done, and come here and go to this block, power GUI, we need to go get power GUI, you can see here, click this one, and you just double click this, make it to discrete, and you just change it to 1 e power minus 6, click OK. That's all. We have done everything. Now we try to execute, run this diagram, and we try to get the graph values. See one more thing. You go to this scope, and you go to this. I've just got the diagram. Anyhow, you try to understand. You go to the settings, and you can see the configuration properties here. Go here, and you see in the display, make this show grid for the active display 2 as well as for the active display 1. You make this show legend here and click OK. Because if you do that, and you can see a block like this. And what is the first one? You can click like this, and you can change the values. So for R, it will be, first thing, it will be current, that means critically damped current. Okay, I can write it as critic current, maybe to understand critic current. And this one, what is this one? We have taken it as over damped, right? So over current. And this one, it will be under current. This is current block and this is voltage block, right? So you click here, change this to be critic voltage, critically damped voltage, condition voltage. And this one, it will be over voltage, and this one, it is nothing but under voltage. That's all. Now we have done everything, and you just close this. Now you come here. Now what we need to do, we need to execute this circuit. For that, you go here, click this run, and you can see that it is compiling and it is running here. You can see it is running. So wait till 100%, and now you see it is completed 100%. Now you go to the scope, double click on the scope. Yes, that's all. First of all, you will get all the values. See, you will get a graph like this, and now you select this one, and you go here, you select this one. You can see like this, it will a plus symbol like this, and you just select this, make this to opposite, click OK. That's all. You will get a graph like this. And now again you select this and then keep this one, and that's all. It can be adjusted. See, first what we try to do, we try to learn the only critically damped current and critically damped voltage. All other two, you just click, it will go off, right? Only this one. Now you see the voltage, maybe current also you can see. Anyhow, you can see the voltage. What is the voltage? This is the steady state part. See, this whole thing here itself, the steady state part has been started. See, at 0.1 second, the steady state part has been started. See the graph. The maximum voltage is around 0.9 voltage, right? So positive 0.9, negative 0.9, and this is the steady state voltage. This is the voltage across the capacitor in critically damped condition. First one is critically damped. Red color is both. This is critically damped voltage and this is critically damped current value. What is the current value? It is 0.03 amperes, right? You can see here, first it is increased to 2.1 voltage, and then it is coming down to 1.25, again it is coming down to 1, and it is coming down to 0.95, and then it is 0.9, 0.9, 0.9. It is going off. It is going off, right? So this is the critically damped condition, and we have seen this one. See, there in DC circuit, voltage will be settled down to 10 volt. If it is 10 volt DC, then it will be settled down to 10. It is going beyond 10 and then it will be coming down to 10, right? It will be reaching 10 at some point, right? That is the critically damped condition. And you just close this one right now, go to over damped, and you close this, go to over damped. See, this is the over damped condition, and you can see the voltage is increasing, and then it is again increasing, and you can see it is just settling down around here. So this is the voltage and this is the value of current. This is the value of current in the critically damped condition, right? We know this one. And then you just close these two, go to underdamped. Underdamped is very important. See what happens in the underdamped. It is going, it is increasing and then it is decreasing to the negative point, and then again it is increasing, decreasing, and then it is settled down to the value of voltage. It is around 1.2, 1 or 1.2 voltage, right? So you are getting the voltage here as well as current here. So what happens here? It is oscillating, right? It is oscillating. That's all. That you cannot see this oscillations in overdamped and critically damped. You can see here, right? So these are all the three different curves, and you can see all the three different curves in the same graph. So you just try to put the values of I of t and v of t in the previous lecture. What are the expressions we have got, and you can compare it with this expression, and you can easily understand the things. Anyhow, we have done all the things with the MATLAB, and I have just given you an outline. If you peoples draw yourself the diagram and you try to solve the numerical examples with a pen and paper, and then you try to compare the manual calculation with the MATLAB, that will give you a clarity about the problems. Try to understand. That has to be done by you, because it is a very little bit very easy to see that the MATLAB expressions, MATLAB Simulink, but while calculating it with pen and paper, it will be very tough. So it will come by experience. So what you do, please try to solve the expressions with pen and paper, and then you just compare it with the MATLAB. MATLAB will not uh, show you a wrong answer. Obviously, it is going to be a correct answer. Maybe with the pen and paper, you people can do small errors and calculation errors will be there, so that you can easily compare. So please you do with the MATLABs, and then you will get a clarity about the problems, right? So only thing you need to understand here, see blue color, it is actually underdamped condition. I have already told you, in underdamped conditions, obviously the voltage across the capacitor is going to oscillate. See, it is increasing. Maybe I will show only the underdamped voltage. It is increasing and then it is coming down here. Again it is increasing in the negative direction. It is coming like this, and then it is settling to the original voltage, right? Only thing, right? I have just clicked it. Now this is the overall voltage and current, and we have seen everything with this one. It will be like this. You try to select like this. You just click here. You can see a block like this. That's all. You can see. If you want to see separate graphs, you click here. You can see all the graphs, or you click here to see only single graphs. That is also possible, and you do everything with your own and try to learn the things, right? So now this is the diagram, and you go through with this diagram, and all these students are asking me to explain the things with MATLAB in RL and RC circuit with AC input. Okay, fine. In the next class, we have already derived the expression for RL and RC circuit with the AC input as well as with the DC input in our previous lectures. Maybe in the next class we will see all RL and RC circuit with AC input and DC input in the MATLAB, and we try to give you a clarity about the graphs and graphs with voltages and current, so that you can easily understand. And then we will wind up the transient responses of RLC circuit, because it is a lengthy lectures. We have taken so many lectures to explain this transient conditions, right? We will see in the next class with the MATLAB, again with the MATLAB for RL and RC circuits with AC and DC input. Thank you. If you have any doubts, please post it in the comments. We will discuss. Thank you. We will see in the next class.